Good morning, everyone, and welcome to Pearl Harbor Aviation Museum. This is going to be our first webinar for 2021, and we're excited to share a message of hope and innovation in aviation to start our year. It is stormy and raining here in Hawaii, so we have a little bit of weather that we would consider our winter weather. And even though we're on Oahu and it's just raining, we do have on the Big Island of Hawaii that it is snowing. So there is snow in Hawaii on the top of Mauna Kea. So the reason we share that with you is to let you know a little bit what's going on, and hopefully our internet connection stays good throughout the entire program. Our museum is open, and hopefully sometime in the future you'll be able to come to Hawaii and visit us in person. So we have some people here with us on the screen. We have several educators that are behind the scenes and helping to keep our program smooth and running. We have Eric and Ashley and Ford, and they help us behind the scenes by monitoring the chat, answering questions on the Q&A. So if you have any comments, please put those in the chat. And if you have any questions for our guest speaker, please put those in the Q&A. Remember our program to be thoughtful and kind in your comments on the chat. Another thing we like is we like to know where you're coming from. We get visitors from all over the United States and from different countries. So please add in the chat where you're watching our program from today. So today we're so very fortunate to have Brice Nzeukou. He is the Director of Business and Product Development for Ampaire. His past experience includes product engineering experiences with power electronics, automotive and robotic industries, and now aviation. So welcome, Brice. We're so happy to have you here and tell us a little bit about the Ampaire story.
Great, thank you so much for having me.
So to start our program off, I found this video, and I think that this video tells us a little bit about Ampaire. It's I think you mentioned it was the first video, the first flight which was conducted in 2019. Is that correct?
Yes.
Okay, let's take a look at this. That is such an awesome video. And I know that your aircraft is an electric aircraft and your company is leaders in innovation. So can you tell us a little bit about how this works?
Sure. So I'd love to actually maybe touch on a little bit of points from that previous video. Kind of in the middle of the video, while we were there filming, and our test pilot kind of came around a short final, came in and he did a little wave to us on the ground filming as well. So that was actually really cool. You can kind of see that in the video. Hello again, everybody. Thank you for joining. My name is Brice Nzeukou, Director of Business and Product Development at Ampaire. And I'd love to introduce you to our technology and what we're doing. So this aircraft, the electric eel, is kind of the first real step in aviation electrification. So this aircraft actually is in a hybrid electric configuration. And we chose this aircraft. It's originally a Cessna 337 Skymaster for a very particular reason. You can see that it has one propeller in the nose and one in the tail. What that allows us to do is actually test different propulsion systems without affecting the flight characteristics of the aircraft too much. So with the standard aircraft that has twin engines, it has engine on the right wing, an engine on the left wing. And when you change one of those out, it makes it a little bit difficult to manage the flight characteristics in a safe way. But for this configuration, an inline twin configuration, it really allowed us to look into that and make those changes. So for this particular aircraft, it's actually the rear that is electric, and you can kind of see in the video, you saw some box, which is actually our inverter, with some wires going out. That's connected to the electric motor. That's then connected to the propeller and turns the propeller. So that is the system that's installed in the rear of the aircraft. And for this particular iteration, we had the batteries installed in the cabin of the aircraft as well. And we had our test pilot and our flight test engineer were the ones that you could hear, the pilot requesting full power, and then Russ, our flight test engineer, confirming that the full power on the electric was there. So that's a little bit about this aircraft. And really, we consider it a first step to aviation electrification because we believe hybrid is a practical and really compelling way to start the shift to electrification. So technology isn't really quite there yet to offer the benefits that customers expect in terms of their own revenue generating capability as an operator versus kind of the cost reduction that you can realize with electrification.
Now, and this picture here is shows a little bit of the electric power, so from inside the aircraft. And we have a question already from Andrew, and he's asking, does the plane have a large battery on its belly?
Right, so the second iteration of our aircraft is where we actually put the battery, shifted it outside of the cabin and underneath the aircraft, and it's attached to the aircraft and covered by a pod. We call it an aero-optimized shell, an aero shell for short. And what we're seeing in this picture is, again, the inverter that I mentioned. And then those orange wires are high voltage wires and control wires going to the electric motor. The blue wire is actually the thermal, or tubing rather, is the thermal system. So we're running a coolant mix in there to cool down the electric motor. And that kind of metal thing you can see behind the propeller is part of the structure that holds the propeller shaft there, and then the motor is just behind that. So previously, if you look at that entire compartment was filled with a 210 horsepower engine. And I can tell you that you need cranes and other things to lift it out of that position. But actually the electric motor and each one of these components individually, I can hold myself. Now they're a little bit heavy. The electric motor I think is around 80 pounds, 80 to 100 pounds, but it's certainly something that you can carry yourself. And it has roughly the same power output capability as that gigantic engine that fit in that space in the first place. And so that's part of this drive to electrification, is that the components are now at a level, at a power density level, an energy density level for the batteries, and even for the power electronics, that they have a high enough power output capability and heat handling capability to be able to output enough power to drive that propeller.
Seems like it's innovating so quickly that you're constantly making changes. This next picture shows the charging station, and so how will this work for commercial aviation?
Right, so this is the picture that kind of first introduces our second iteration of the aircraft, where you can see very clearly underneath the aircraft we have that pod, and that's where our battery is connected. And for this aircraft, and this is the one pretty obviously for those who've flown out of the commuter terminal at Kahului Airport, that's where we are. That's the plane that was in Hawaii. And it's actually the front of this aircraft that's electric. So we took roughly the same system, lightweighted it a little bit and made some upgrades and changes and put it in the front. And that was actually driven, in large part by the weight and balance of the aircraft. For those who are familiar with aviation, the weight and balance of an aircraft is very important and affects how the aircraft flies, and really whether it's safe to fly. And so we really made that choice, and also looking at installations in the front a tractor prop. We really want to be able to demonstrate that with a measure of electrification. This system, when I say hybrid, it's actually it's actually technically called a parallel hybrid system. So it's two propulsion systems that are completely independent. So we have a fully electric system up front. So the batteries are connected directly to the electric motor and the inverter system, and that's what powers that front propeller. And then in the rear, we have the combustion engine. It's actually an up-engine aircraft. It's instead of the standard 210 horsepower, we actually bumped it up to 300 horsepower. That's just for better single-engine performance and overall safety of the aircraft. The fuel tanks are still in the wings, and those feed that combustion engine, that piston engine in the rear. So what you're seeing here is Justin Gillen, our test pilot and kind of Hawaii program project manager, who kind of managed almost from soup to nuts our entire operations while we were in Hawaii. And so he's right now charging the aircraft. So when he plugs it in there, that's charging the batteries. And that charger is the first charger to be developed with a new global standard for electric aircraft charging that's being developed on a global level. And so that aircraft right now needs to be plugged in, or sorry, that charger needs to be plugged into the grid for it to be able to charge. And so that's kind of one of the limitations we see moving forward, but we're working hard to remove those barriers.
We've had a few questions about the energy power source. Andrew's asking, what voltage does the motor run on, and what is considered high voltage?
Sure. So I think technically high voltage is, I want to say above. Well, let me not speculate. But we're operating at a voltage above 600 volts. So that's high voltage. We consider that high voltage. And not quite sure exactly what the electric motor runs on. That's driven by the inverter, but the battery system is above 600 volts.
And another question from Kevin is, what is the time that it takes to fully charge and the duration that it lasts on a normal cruise?
Right. So the time that it takes to fully charge with the right kind of grid power available, it can take about an hour to an hour and a half to fully charge the battery. Now, when we talk about how to operate this aircraft, there's a ton of different nuances. Much like a hybrid car, let's take a Prius, for example, although it's not necessarily a one-to-one, a direct one-to-one comparison. But if you drive a Prius like a race car, you're not going to get the full benefits of kind of the fuel reduction and the efficiency that that architecture offers. And so similarly for this aircraft, there's a specific way to fly it to maximize your range, to maximize your speed, or to maximize your cost savings. So kind of those are the three different operating points that you can really kind of plan for. If you wanted to do a fully electric cruise, you likely wouldn't be able to do that for too long, especially because it's only a single engine. So the way that we operate the aircraft is you take off with both at full power. Actually, for this aircraft, we actually have the electric motor at kind of like a flex power around like 70%, I believe, during takeoff, because we have the upsized 300 horsepower combustion engine in the back. And when we take off and we get to our cruise altitude, we actually pull down the electric motor, pull down the combustion motor as well, and fly mainly using the combustion engine. We do this for a couple of reasons. One is to conserve the battery power, and baselining this kind of operation allows you to make the battery pack smaller. For those familiar with the kind of electrification, batteries are really heavy. There's billions of dollars in the industry being kind of dumped into research and development to reduce the weight of batteries and increase their energy. So the specific energy density of batteries is a real kind of driver for ground electric vehicles, as well as especially for aviation, where weight is very important. So kind of that kind of optimization problem for us is really what drove the battery size. how we plan to operate the aircraft. So on fully electric, you could probably go 15 to 30 minutes. I believe it's sized for the reserve requirements and VFR, visual flight rules. I believe it's about 30 minutes that we'll need to fly in case of a emergency scenario. So that's I think about right for how long you can fly fully electric. But combined and kind of the most optimized for range, you could fly for hours. This aircraft flew for 2.5 hours. That's a mix of combustion and electric from the Southern California area to the Bay Area. So it was a 341-mile flight.
Oh, that's amazing. And I think that Ampaire is one of the leaders and possibly the leader in this innovative technology. So the timeline seems to be fairly quick and it's fairly recent. Can you tell us a little bit about where Ampaire is on this timeline and specifically these aircraft?
Sure. So this particular aircraft, the electric eel, is really a test bed for Ampaire. It's where we test our propulsion systems. It's where we test a lot of our battery systems. It's where we've done upgrades to our avionics, our software. But really, we're looking to scale this technology to larger aircraft. We've been working with NASA, or been funded by NASA, to research scaling up our technology to a 19-passenger aircraft, the Twin Otter. And so that's one kind of path that we're looking at. As well as other aircraft in kind of this 19-seat and below category. Mm-hmm. So where we are right now is we're targeting to have 1 to 2 aircraft commercially available by the first one by the end of 2023, and likely the second one by end of 2024 or early 2025.
I think it's amazing. We watched the earlier video from 2019 when you did your first flight, and then 1 year later in 2020, you were flying in a partnership with Mokulele and Elemental Accelerator. Can you tell us a little bit about the partnership and that flight that helped to move the technology forward?
Right. So this entire demonstration program really would not have been possible without our partners, primarily Elemental Accelerator and Mokulele Airlines. Elemental Accelerator is a startup accelerator based in Honolulu, and they look at supporting a whole measure of clean tech organizations and startups that have a focus for kind of bringing technology and benefits both to the local Hawaii community and worldwide. And so our relationship with Mokulele as well was really the perfect mix, us, Elemental and Mokulele, to really put together a demonstration flight where Mokulele acted as the hosts. Their hangar on the private side of Kahului Airport is where we stored our aircraft. We were able to leverage, some of their mechanics to put our aircraft back together. It's already a long distance for commercial aircraft to fly all the way to Hawaii. So our hybrid electric, although it has a record flight length at 341 miles. It can't make that 2,600 mile trip. So we had to disassemble it. And that's actually the reason for that trip to the Bay Area. There were specialists there that knew how to disassemble aircraft and package them safely so that they could be shipped by sea. So we leveraged their support, putting our aircraft back together. Their pilots ended up flying our plane with our test pilot as well. So we got a lot of good feedback from them about how the system handles. And really, kind of that feedback has been, it's much more simple than a traditional aircraft, especially for a twin aircraft, where you have, 2 combustion systems to monitor and to make sure that they're operating well. And for Mokulele, normally they just have one with the Cessna Caravan here. But for our system, the electric system, is extremely simple. You just ask for a power, and it kind of stays there, and it manages without having to look at fuel pressure or oil temperature or all these other things. This is really a very simplified system. So it was a great partnership to work with them. We got a lot of benefit out of them, and we're now exploring with Mokulele how to really bring this technology to their fleet. And we are looking at the Cessna Caravan as an upgrade model for us to upgrade this aircraft to hybrid electric.
All right, well, I wanted to show our viewers that flight from the historic flight that took place in November just of last year. So let's watch this one, and so they can experience the flight too.
Right, and I will caveat this that this flight wasn't particularly that flight. We didn't have a camera crew at that time, but what we're seeing here,
world's first.
What we're seeing here is the aircraft in Hawaii, and this is kind of for Hawaii the record flight, and a really great representation of just the beauty of the landscape and really the technology and the sustainability that electric aviation can bring.
All right, thanks a lot, Brice.
The chain of islands here in Hawaii offer a unique transportation challenge where travel is necessary for short distances. At Ampaire, one of the key words in our mission is being trusted, a trusted developer of practical, compelling electric planes. This program couldn't have been possible without Elemental Accelerator, Mokulele Airlines, and Southern Airways, who are actually shifting the structure of the industry from large planes down into these smaller regional planes, which ultimately are also more sustainable.
These test flights are really the culmination of hundreds and hundreds, not thousands and thousands of hours that people have put in to make this happen. The hangars have been rewired, the new power supply is there, and we're ready to go.
Seeing Ampaire's role and how they can help communities is really inspiring.
I love that video. I really do.
It's really awesome to just watch that, and really it tugs at our hearts because we're here in Hawaii, and it's something special for our state. So, I guess that leads to the next question: what are the benefits of electric flights here in Hawaii?
Right. So the benefits of electrification really are twofold. One is from the operator's perspective, and one is from kind of the general flying public. From the operator's perspective, and kind of the reason why we are pursuing this this business and this technology is the efficiencies that can bring in direct operating cost for our operators. This really is a win-win scenario where we have better environmental impact, lower emissions, lower cost, which can be that economic driver to bring sustainability. So here on the left side of this chart, you can kind of see in a traditional fuel aircraft, you could expect to pay maybe $100 in fuel. Going to the near-term hybrid, that drops, and then long-term electric, that drops significantly as well. But really, this is the progression of the cost efficiencies that we'll see over the next decade as a battery technology gets better and as infrastructure gets rolled out to more and more airports. And that's really what we're looking to bring. And when you consider the different modes of transportation, I mean, the road from kind of Kahului to Hana is kind of a famous route. And to fly it takes less than 20 minutes, but to drive it takes over 2 hours. And so when you think about kind of the time saving for people at that lower operating cost point, which eventually means lower fares as well. So we kind of really do believe that electric aviation is going to put a downward pressure on the cost of aviation. And really what we're going to see is a couple things. One is routes being opened up to communities that have never had reliable service before, and increased access to air mobility in general. And we're looking at not only Hawaii, but this is really true to a lot of emerging markets, as well as a lot of areas in the US.
I can see many benefits to this, and also for safety too. The road to Hana is dangerous, but I think of also medical reasons. A lot of people travel for medical reasons, so I can see benefits in those areas as well. You had this innovation here has some significance with this flight that you had in California. Can you tell us a little bit about that one?
Right, so flying from Camarillo Airport, that's a little bit north of the Los Angeles area in Ventura County, all the way up to Hayward, California, just south of Oakland, I believe. That was a record flight for us. Like I mentioned earlier, it was 341 miles, 2.5 hours. I can tell you that our entire team was kind of glued to our computers during the 2.5 hours, making sure that the flight was going well. We were tracking the flight and seeing its progress. But that actually was the end of a series of flight tests that we do in what's the FAA calls the experimental airworthiness category. So we were kind of in a research and development phase. And kind of what kicked off that flight was the ability for us to go into what's called a market survey, which is the kind of regulatory category that we were in to allow our flights in Hawaii. But during that testing phase, we flew 24 times in 28 days, that 33.5 flight hours with 100% dispatch reliability. I'm going to start with the 24 flights in 28 days. That is a heroic effort from our test pilot. Really, Justin Gillen is really a great professional and has a great background, as well as the rest of our flight ops team, including our general manager, Doug Shane, who is a storied test pilot at Scaled Composites, which is actually where Justin comes from as well. So really, really great effort from him. 33.5 flight hours. Understanding from Doug and Justin that's a lot of hours to put on a novel aircraft and novel technology, and 100% dispatch reliability. What that means is there were no issues with the new system that prevented us from flying when we wanted to. That meant everything worked exactly as it should. There were likely some kinks, maybe some software, some UI that we messed around with just to make sure that things were better optimized. But from fundamentals of the powertrain technology, there were zero issues. And that's actually true of our first flight test program back in 2019 as well, is that we had zero issues with that aircraft. So this was a really great testament to the maturity of our flight test organization at Ampaire.
It sounds like that. I'm sure that doesn't come without a lot of hard work and expertise in every area that's involved. So that's not something that just happens. So 100% reliability. And so here is, we're back here in Hawaii. So tell us a little bit about the impact this could have in Hawaii.
Right, so again, Justin, our test pilot flew multiple times around the island. Our target was to replicate a commercial route that's flown by Southern Airways or Mokulele Airlines or Makani Kai. They've all kind of been consolidated into under the umbrella of Southern Airways. And so that flight from Kahului to Hana, we did that several times and have some data to back up some of our fuel reduction as well, and kind of the time it takes to operate those routes. But we flew, 22 flights. I think that includes the media flight that you just saw in the video. And that media flight actually, I think, was maybe even over 2.5 hours. So we say that flight from Camarillo was our record flight by distance, but I think by endurance, by time, it actually might be that media flight to capture all the great footage all over Maui. So we were trying to shoot for an operational cadence of 2 flights per day. Some weather prevented us from doing that, but that was always expected to happen. But we were able to get 23.6 flight hours in. That's fantastic, also with 100% dispatch reliability. So again, our kind of the hero of the day was our test pilot for managing this program for us.
So the next thing we wonder is where are you going next with this?
Right, so as I mentioned earlier, we are looking to scale the technology to larger aircraft. You kind of see a couple here. You see our electric eel, you see a representation of a twin Otter that could have 4 propellers on it, 4 propulsors. kind of turning it from a twin otter to kind of a quad configuration. We also have the caravan down there. And then up in the upper corner, we have the tailwind. The tailwind is kind of our North Star. It's where we kind of envision an entirely fully energy optimized aircraft, fully electric at some point in the future, kind of throwing all the technology kind of into that configuration to make it extremely efficient. Much like ground EVs are all kind of fighting for any kind of percentage point benefit and efficiency, that extends their range, extends their market. It's exactly the same for aviation as well. So scaling up this technology, those two aircraft at the bottom, we're looking to get those rolled out in the next 3 to 4 years.
And here's a little closer view of the Otter that you were talking about. Maybe you can give a little more details now that we have this close up.
Yeah, so this is a picture of the conventional Twin Otter. For those who aren't familiar with the aircraft, it's a 19-passenger aircraft originally, and we're looking at upgrading it to a hybrid configuration. And so what that would involve is a kind of replacing those turboprops with our kind of novel electric powertrain system. But the benefits that we would get are actually quite substantial. We're looking at above 10 to 15% reduction in fuel and direct operating costs, with kind of range above 200 miles. We actually just put 200 plus miles there because the range is actually quite long. In some instances and in some kind of configurations we looked at, the range was actually longer than the conventional aircraft. Although I don't think anyone's flying 800 nautical miles in an aircraft like this anyways. But we are able to maintain a significant amount of the payload of the aircraft. One of the kind of the criticisms of electric aviation is that you decrease the payload because you need to allocate a lot of that for batteries. But for this particular configuration, we've been able to maximize the payload. And for some short routes, which is really what these aircraft are focused on, you can carry a significant amount of passengers, as well as cargo and payload. So over 4,000 pounds of payload for the Eco Otter SX. And the SX kind of stands, so it's a kind of differentiated for us that signifies a series hybrid architecture, which is a little bit different from what the electric eel is. The series hybrid is more analogous to a Prius, where you have a combustion engine that can charge a battery in the air, and that can also power directly the electric motors, or in this case, the propellers.
So I'm appreciative of the efforts that your company is making for sustainable, clean energy and helping to reduce some of the pollution in our environment. One of our viewers was asking why, it was Charles, he's asking, why have you chosen batteries over hydrogen fuel cells?
Right, the battery versus, and it's really not battery versus hydrogen. We actually like to think of electric aviation as this really collaborative industry, actually. So we believe it's battery and hydrogen. So kind of Ampaire's mission is to be the world's most trusted developer of practical, compelling electric aircraft, from short haul cargo, those are flights like the ones from Kahului to Hana, all the way up to supersonic passenger transport at someday. But kind of our focus is being the world leaders and being able to integrate new technologies in novel ways to bring about compelling results for operators, reduced emissions, and our ultimate sustainable goal for aviation. So we focused on battery electric for a couple reasons. One, we feel like that is the quickest path to market. That's what we've been laser focused on doing, is how do we enter the market with a configuration that delivers value to customers, and really that's the economic value is what's driving our strategy and driving our path forward for our roadmap.
Another one of our members in the audience, Olaf, is asking, how close are you to certification with this configuration?
So if we're talking about a series hybrid configuration, we're kind of still in the product development phase. So we are kind of ironing out some of the kinks in the system, looking at supply base, and developing our supply chain as well. And so we're kind of in that finalization phase for our system. And so our target for certification again, by the end of 2023, and also our second aircraft by about a year and a half from there.
I think we haven't touched on this one yet. You mentioned it when you had all 4 aircrafts on that slide, but this one here, let's hear some more about this one.
Sure. So the Tailwind, as I mentioned, is our fully energy optimized aircraft. And it is kind of the brainchild of our co-founder, Corey Combs. So Corey really was the driver for this design. And so it takes into account a lot of novel technologies. One is a ducted fan in the rear of the aircraft that utilizes what's called boundary layer ingestion to increase the aero efficiency of the overall aircraft. It has a high aspect ratio wing, that kind of striking, really long wing, and larger wings mean kind of better lift and lift to drag ratio as well. So that's really what kind of the key drivers for this. And there are a couple other bells and whistles in here as well. But the goal is for this aircraft to be fully electric and could also come in a hybrid configuration. But again, this is our North Star. There's no timeline for when this aircraft would come out. We're focused on proving out our upgrade model. But this is kind of the kind of thinking and technology that we want to bring to market in the long term.
It's nice to see the
and
for the future.
Just a couple more tidbits. This would be a 9-passenger aircraft.
Mm-hmm. And this picture, I have to say, I love this one the most because you can tell that there was something really exciting happening at this moment. But also what I love about it is that each person had a different role on the team that for whatever you were accomplishing at that moment. And so when kids nowadays look to the field of aviation as a possible career, I love that this represents that there were many different people involved in that flight, that first hybrid flight or any of the electric flights that you've done since then. So I think if you could tell us a little bit about the career path that you took. So you started out as a mechanical engineer at Caltech, and then you ended up as a product designer and business development here at Ampaire. So can you tell, for the youth that are watching this program, how did you go from an engineering major in college to the career field that you currently have?
Sure. So before I answer that question, I just really want to explain what's going on in this picture. This was an extremely windy day in Maui when we were doing our community engagement event. And just the people that are in here, there's me on the left of the screen, and then you have Justin Gillen, our test pilot, moving right, and then we have Doug Shane, our general manager, as well as, and then on the end is Kevin Ork, our co-founder and CEO. So those are the people who are jumping for joy. I actually convinced everyone to do a jump while we're doing kind of a photo shoot here. So this was a really fun photo. And like you mentioned, there is a whole team that does it, and that's gotten us to this point so far. And really, it's a testament to that team and the culture that Kevin and Corey, our co-founders, have built at Ampaire to really be able to drive this innovation and drive this technology forward. And with the experience in the industry from someone like Doug, our general manager, especially where his own storied history of flight testing and being a test pilot is really really a driver for our team. So my own personal story, I studied mechanical engineering and business economics and management at Caltech. I went and worked for a defense contractor right out of school. And the organization, Iris Technology, was founded by actually a Caltech alumni. I think he was class of 76 at the time. And so Ed, the CEO of Iris Technology, really allowed people within his organization, company, to really kind of explore their interests. And at that point, I realized that, maybe I didn't want to do mechanical engineering and kind of follow that super technical specialized role, and started exploring more kind of the product business development, sales, and kind of driving business forward. So I took that kind of path throughout my career, going from there to working at another startup in the robotics industry. That company was SynTouch Inc., a great company if you want to look into them. They are quantifying the sense of touch. So if you want to know more about that, I'd suggest you do some research. A fantastic organization. And then from there, ended up at Honeywell, which ended up into spinning off into Garrett Advancing Motion, working in the transportation systems business, and kind of having that technical background plus kind of more experience in kind of product development and kind of business management. That's really where I got that experience at Honeywell. I was managing an entire business line from a product management perspective globally. So that was really a formative opportunity for me. And Kevin is an alumni of Caltech. He's class of 2009. I'm class of 2013. So we didn't overlap, but we were part of the same alumni circles. And it was actually back in 2016 that I saw on LinkedIn that Kevin had started Ampaire. And I thought that was the coolest thing that I ever heard of. So immediately reached out to him, and I actually met the whole founding team way back in 2016. But it turned out to not be quite the best fit at the time for what their staffing plan was. But fast forward, 2 years later, November of 2018, that's when I joined the team. And actually my first day at Ampaire was actually headed over to LAX to fly to Norway to support Kevin and Corey at an accelerator program, the Techstars Energy Accelerator Program in Oslo. So kind of a crazy first day there.
Okay, I've got a lot of questions that have come up, and before I get off this screen, I wanted to ask a couple sort of related questions. First of all, right now, there's a lot of college students that are studying engineering and economics and business development, but they're doing it virtually through a computer, and I imagine it's quite difficult to sustain that interest in that hard work that's necessary to be successful in this career. So do you have any advice for the college students of today on how to persist through challenges and end up with a joyful career that you are demonstrating here?
Yeah, I think you have to explore. You have to kind of do the research of what you may be interested in, reach out to people. I think one of kind of the way that the I'll say the startup ecosystem is kind of set up right now, I think really provides a good way for people who want to get involved in certain industries to offer the opportunity for them to. For example, there are a lot of internship programs through startup accelerators. So you don't necessarily have to reach out directly to a company that may be a portfolio of Elemental Accelerator, for example, or Y Combinator, or even Techstars. You can reach out to that organization themselves and search for companies that may be looking for help and offering internships for the summer. Some startup accelerators are industry specific, industry focused. There are a ton of biomed startups. We're part of the Starburst Aerospace Startup Accelerator, which is the largest aerospace accelerator worldwide. A ton of space technology, aviation, everything from software to hardware. So there are a lot of opportunities, I think, for people to do a lot of research. And I'm advocating for kind of getting involved in the startup world early on for a lot of college grads who, want kind of that entrepreneurial experience. Mm-hmm. But I will say, there are great things at big companies, a ton of great processes. And there's great things there, and there's things that don't quite work, I think, at big companies. And it's the same at startups. And so kind of exploring and getting that exposure is really what I would advocate for.
That's excellent advice. In fact, I was just talking to Roya Dennis over at Elemental Accelerator about their scholarships that their internships that they're offering in other companies. And I think they have about 20 or so internships, and several of them are located here in Hawaii. So hopefully some of the people that are watching will check that out. And a lot of them are remote as well. So even if you're located here in Hawaii, you could participate in those. So thanks for that advice. Another question that's related to this picture is the shirts that you're wearing. So we have some audience members that love those shirts. Are those Ampaire specific, and how do we get those?
These are Ampaire specific Aloha shirts. So our in-house designer worked with Kevin. This is actually a surprise to the whole team. they colluded to develop this themselves and presented it to the team, kind of as a great way to bond the team. So these are an exclusive shirt. Unfortunately, they're not available publicly. They're only for Ampaire, or we call ourselves Ampères. So they're only for Ampères, unfortunately. But this is just a great way to kind of show a little bit of deference towards the culture in Hawaii and understanding of the values of the area that we're trying to operate in.
Thank you for that. I'm going to go on, try to address some of these other questions that people are asking. So thanks for sharing all those images to help us understand your company and the flights better. So the questions I have are related to the power source, the aircrafts, and some other partnerships that you've had. So I think I'm going to start with the power source. Let's see, we've got, let me just scroll here. It's from Freeman. He's asking about, is there any emphasis or any effort put into alleviating the mass of the electric motor?
Yeah, so the power density of the electric motors is what a lot of companies are looking at. We don't manufacture those electric motors in-house, so we're working with the supply chain to kind of drive them to our requirements. And so reducing the weight for kind of wherever we can find weight reduction has been a real priority for our engineering organization. But that's not something that we technically drive ourselves, but we do kind of have these standards that our suppliers have to meet.
And so Crichton is asking that understand that the electric motor is lighter than the original engine. However, is it still lighter when the weight of the batteries are included?
So if you're talking about the whole mass of the propulsion system, and we actually like to think about this slightly differently. So we take the electric motor, the inverter, which is kind of controls the motor. We take that combination, we call it an electric propulsion unit. And it's that we actually compare to an engine. So the battery we consider as fuel. So we would kind of say you're displacing kind of energy and fuel usage with a battery, but that's coming at an added weight. So that does kind of impact the overall payload or useful load for the aircraft. But in terms of kind of how we technically classify that difference between the electric motor and the battery and the conventional engine, there's a small nuances there. But overall, the powertrain, including the battery, is heavier than the original.
A question about the charging device. Is the charging device for the aircraft, can that also be used for automobiles?
Potentially, as long as it has the proper kind of charge method, the proper plug. There's CHAdeMO, there's the other global standards for charging. That would be up to the manufacturers of the charger to drive that. But we actually think that airports in the future will become these green energy hubs. A lot of airports are looking at installing solar panels and getting a lot of their kind of electricity more renewable. And we think that's a great trend for airports in general. And so you have a lot of renewable energy going into to power these renewable aircraft, and electric cars, electric tugs, and other kind of electric shuttle buses around. So we really think that airports will need to work with utilities, and to the extent that utilities can also green their grids, that's really what we're advocating for.
Some great partnerships in the future. Some more questions about the aircraft specifics. This is from Dennis. Does the motor drive the propeller directly, or is there a gearbox or clutch between them?
There is no gearbox, no clutch. It does drive the propeller shaft directly. So the motor itself does spin at the same RPM that the propeller does. And I think that is around, I think 2,200 RPM is the max that we spin at. Well, not the max capability of the motor, but the max for our aircraft.
And then another question also from Dennis is, do the electric props move when dormant?
They can. So when kind of the system totally shuts off, and we actually experienced this on very windy days, the propeller will actually start turning, kind of slowly. It's the same actually if you look at, large airports, large aircraft. If it's a windy day and you're staying at your terminal, you can kind of see the fan inside those giant engines also turn slowly with the wind. So it's kind of the same.
Okay, another more specific question. So from Charles, what are the dual scoops for on top of the rear engine air intake scoop?
Right. So originally that aircraft was fitted for a 210 horsepower engine, which has its own kind of mass flow, mass intake rate. And so those additional scoops is just to increase the air coming into the engine to be able to produce the power output. So it's just more air needed for the engine.
Okay, thank you for that. And Brent, he was asking if you could describe boundary layer ingestion.
Sure. Boundary layer ingestion. If you're familiar with the term laminar flow, it's air that's very straight and smooth. As an aircraft goes through the air, it kind of disrupts that laminar flow, and that gets it's almost analogous to friction. It gets very turbulent the closer you get to the aircraft. But if you can make that, and there's a lot of energy lost in kind of that boundary layer, and so it's a less efficient. It increases the overall drag of the aircraft. So if you can make that boundary layer smaller, you can reduce the drag. And so the ducted fan kind of sucks in the air kind of in that boundary layer and laminarizes that flow. And so you have a smaller boundary layer, less drag, more efficiency.
Right. And then one final kind of specific question is from Charles. For the Otter, is the hybrid portion a small APU engine driving a generator that charges the batteries which power 4 propulsors?
Yeah, that's just about right. We haven't finalized our technical configuration, so I'm not going to necessarily, say that that's the exact production configuration rather. But it is a turbo generator that's going to be driving the electric motors and also charging the batteries in cruise, and then working with the batteries to power the propulsors during the takeoff.
And then we have a couple of more questions, and these are more about relationships that you've had with other organizations. And so from Admiral Zlatoper, he's asking, have you had any interaction with the Slovenian company, and I don't know if this is correct, my pronunciation, but Pipistrel? Yeah,
that is the correct pronunciation, Pipistrel. Pipistrel has done a great job on kind of the small aircraft. They have a 2-seater, fully electric aircraft. I think it's the Alpha Electro aircraft. And there's no kind of formal relationship between Ampaire and Pipistrel. But our founders, know their CTO and their organization. So it's kind of a kind of small industry right now. So kind of everyone kind of knows each other. So there is some familiarity there.
And then a quick question, and back to the specific for the aircraft. I want to make sure I try to get everyone's questions answered. But the question is, do you use variable pitch propellers?
So we are looking at the differences in the technical trade between variable pitch propellers and fixed pitch propellers. So that's not a technical trade that we've fully closed yet. There are a couple different factors to consider, like weight as well. It's that one thing that we really want to minimize. But there's an efficiency trade-off, propulsive efficiency trade-off there too. So that's something that we're looking into.
And then I think this will be our final question. This is another one, a relationship question. Is Ampaire also involved with the electrified, again, pronunciation, de Havilland Beaver in Washington State?
We were not involved in that program. That program was driven by a company, I believe that's Magni X, and also the operator of those aircraft, Harbor Air. And so their partnership produced that aircraft, and we really applaud anyone doing anything in this space. We believe that the more that people are focusing and trying to develop this technology, the better the sustainable future is going to be for aviation.
Mm-hmm. I love that message, and that actually leads to our next webinar. I think that you and I had talked about it, but just to let our viewers know, our next webinar is going to be on February 12th with a company called Zero Avia, and they are using the hydrogen propulsion for their power source. And so I know we had some questions about that today, but I love the idea that everyone is working together for the same goal, but just in different ways. So hopefully all to help us with some sustainable, clean energy.
Definitely.
Yeah, so Brice, we're so grateful that you're here with us in this program, and we've learned so much from our time with you today. So we're about ended our time. Do you have anything else that maybe we didn't cover that you want to make sure that you tell our viewers?
Sure. We are hiring for largely technical roles. So you can check on our website at ampaire.com/careers. To really dig into kind of, if kind of your background fits with some of our current needs for our engineering organization. Really, we're focused on kind of really what's the practical way to get this technology into the market. If you want to come be a part of that, then go to our website.
One of our viewers has asked, do you need an aviation attorney?
I think we have a law firm that we work with at the moment. That's not my area of expertise, but sure, send an email to info@ampaire, and we'll maybe get it to the right person.
You never know, right? You never know where your company, the direction you will go, I would imagine. So even if it's not available now, it never hurts to start a conversation. So thank you so much, Brice, for telling us about Ampaire, telling us about the flights and the impact on our home state of Hawaii. So we're very grateful for your time, your expertise, and just being with us here today.
Thank you, Monica, for having me.
Yeah, so I love to hear your story. And so thank you to all of our viewers who have come to join us for this program and asking the questions. If you didn't happen to see the whole entire program, we do convert this webinar into a YouTube video. It does take a little time for the technical conversion. And so we post that within a few days on our YouTube channel, and it's also on the website. So you can check back in if you want to see that. But otherwise, on behalf of Pearl Harbor Aviation Museum, we hope you have a great day, and thanks for joining us. Oh, aloha.
Aloha. Mahalo.